Okay, today our question is first question is if f of x equal x square cos 1 by x for x does not equal to 0, 0 for x equal to 0, find f dash 0. The question is this. Now the solution is here f of x is x square cos 1 by x and f of 0 is 0. Now f of 0 plus s equals 0 plus s whole square. You can put here cos 1 by 0 plus h equal h square times cos 1 by h. Now f dash 0 equal limit s tends to 0 f 0 plus s like f dash a equal f of a plus s minus f of a over h. Limit s tends to 0. Okay. Similarly, f dash 0 equal limit s tends to 0 f of 0 plus s minus f of 0 by h. Limit s tends to 0 and f of 0 plus s. What did you find here? H square cos 1 by h minus f of 0 you find here, that is 0 by h, and dividing by that h, limit s tends to 0 s times cos 1 by s equal s tends to 0 times something is 0, therefore f dash 0 is 0. Okay, now the next question, if f of x equal 3 plus 2x for minus 3 by 2 less or equal than x less or equal than 0, 3 minus 2x for 0 less than x less than 3 by 2, and so that f of x is continuous x equal to 0 but f dash 0 does not exist, continuous but not derivable. So 8x equal to 0, so you need to find which is for left hand derivative, or which function is for left hand derivative, which function is for right hand derivative, and which is function is for left hand limit and which is for right hand limit. So with the help of this part, here x is greater than 0, x is greater than 0, that's why this is this x is towards right. Here x is equal or is smaller than 0, so this function is for left and functional value. This is for, from this part you can observe, this is for functional value and left hand limit or derivative. This is for right, this is for right, this is for left and functional. First you have to judge, you have to check, or you have to identify that relation if such questions are given. Now left hand limit at x equal to 0, limit x tends to 0 minus f of x equal limit x tends to 0 minus left ko lagi I already told you this, 3 plus 2x, if x is 0 you will get 3. For right hand limit at x equal to 0, 0 plus f of x, limit x tends to 0, this is for right, 3 minus 2x. If sorry, if x is 0 then you will get 3. And for the functional value, this is for functional value, 3 plus 2 times 0 is 3. Left hand limit, right hand limit, functional value all are equal, so f of x is continuous at x equal to 0. First part is this, and whether it is derivable or not, in that particular point we have to check the second part. Again for left hand derivative, limit s tends to 0, 0 minus h minus f of 0 minus h. So dear student, I will show next slide to make it clear why I have written here minus. In what case we have to write minus, in what case we have to write plus. If simply look at here, this is a 0 point, this is left side, this is right side, so this is x equal to a. So if you want to write this distance is s distance, so f of 0 minus s, in that case you have to put here, for left hand derivative you have to put here minus h. Okay, that is s minus limit 0 minus s minus f of 0 by minus s, limit s tends to 0, f of minus s minus f of 0 by minus h. So for minus s, 3 minus 2s minus 3 by minus s, 3 3 cancel, minus minus cancel, ehs cancel, limit s tends to 0, 2 2 is the left hand derivative. For right hand derivative, limit s tends to 0, 0 plus s, here 0 minus s, so minus here 0 plus s, So minus f of 0 by h, f of s minus f of 0 by h, 3 minus 2s minus 3 by s, minus 2s by h, minus 2 minus 2. Left hand derivatives does not equal to right hand derivative, hence f dash 0 does not exist. And here I want to highlight you that here I have shown in some books or in some textbook or by the some writers, they use for left hand derivative and right hand derivative this plus format. If you use 0 plus s by 0 plus s minus f of 0 by s, in that case that will be also positive. It will be also positive, it won't be negative, so it will be positive. If you use 0 plus s like right hand derivative, it will be in positive form. If 0 minus h if you use, in that case the divisible or divisor, or that is denominator is also minus, both is plus, and in that case the function will be 3 plus 2s minus 3 by h, that will be 2h by h, you will get 2, and right hand derivative no doubt that is minus 2, which is not equal. So be clear about this concept. Now the next question, my dear students, find dy by dx if y equal to x root under x square minus a square by 2 minus a square by 2 log x plus root under x square minus a square. It's a little bit long question anyway, but we can easily solve these questions. We have to find the derivative dy by dx of this question. So we have given y equal to all this question, differentiating both sides with respect to x, then we get dy by dx equal d by dx of first part minus d by dx of second part. This is the first step. Now this x dot root under x square minus a square by 2 is 1 by 2 taking out, then x, this is first expression, this is second expression. So using product properties, first no change derivative of second plus second no change derivative of first, we have applied here UB form. First no change derivative of second plus second no change root under x square minus a square no change derivative of x, that is dx by dx, minus to the right side, this side, a square by 2 is constant, d by dx of log x plus root under x square minus a square. And the next step, 1 by 2 times x as it is, derivative of root under x square a square, that is their power is x square minus a square to the power 1 by 2. We can differentiate with respect to x square minus a square. Okay, so derivative of x square minus a square to the power 1 by 2 with respect to the dx square a square, again dx square minus a square with respect to dx, plus the second part is root under x square minus a square, dx is 1. This part is completed. And the second side, next side, a square by 2 times derivative of log x, so derivative of log x plus root under x square minus a square with respect to x, so that is dx plus root under x square a square times dx plus root under x square minus a square by dx. In this way we can complete this part. Now the next step, 1 by 2, now derivative. Now from here once discuss, and next step we can go 1 by 2 times x as it is, the derivative of n x n minus 1, you can apply n x is what, x square minus a square n minus 1, and it will be minus 1 by 2 power, that's why it will be 1 by 2 times root under x square minus a square. As I mentioned you, it will be minus 1 by power 1 by 2 times x square minus a square to the power 1 minus 1 by 2, it goes down by making root under sign. For this part, here the derivative of x square is 2x, a square is 0, you will get 2x here and here as it is, and here derivative of log x is 1 by x, means 1 by all this term, and here derivative of this x is 1 plus this one is root under x square minus a square, again in the same pattern as here. Okay, so first 1 by 2 x, 1 by 2 times root under x square minus a square times 2x plus root under x square minus a square. I have already explained this. And a square by 2 minus a square by 2, 1 by x plus root under x square a square, that is log x is 1 by x and x is 1, and remaining part is like this first part. So it is 2x by 2 root under x square minus a square. If you compare this part and if you compare this part, which is the same, what property we have applied here, what condition, what system we have applied here, there is a same person or same system. After that 1 by 2 times this x and this x, these two to cancel, x square, and we have taken root under x square minus a square LCM. So in this part x square, and the product of these two is x square minus a square. This is completed, minus a square by 2 times this times 1 is this. Before that, let me check, a square by 2, 1 by x plus root under x square minus a square, this times, if we have taken this common, root under x square minus a square, one time this is root under 2 to cancel, then this is LCM x square minus a square, root under x square minus a square plus this is x. So if we compare these two format, x plus root under x square minus a square, x plus root under x square minus a square. So we have cancelled this. Then the remaining term is 1 by 2 times x square x plus 2x square minus a square or root under x square minus a square minus a square by 2 times root under x square minus a square. Then they have the same denominator, 2 root under x square minus a square, here is 2x square minus a square, and here the numerator is a square, minus a square is minus 2a square. Then 2 is common, x square minus a square, 2 times root under x square minus a square. Then 2 to cancel, x square minus a square is root under x square minus a square times root under x square minus a square over root under x square minus a square. This to cancel, therefore dy by dx equal to root under x square minus a square is the answer. In this way we can find the solution of this question. Now we have to move to the next type of question, means next question which is similar to these questions but something is different here. So find dy by dx if y equal to x root under x a square minus x square by 2 plus a square by 2 sine inverse x by a. This is the question. So here y is given this. Differentiating both sides with respect to x, then we get dy by dx, dy by dx of first part plus dy by dx of second part. Now 1 by 2 common, and as like previous question, first and second part. First no change, derivative of second, plus second no change, derivative of first. This part is completed, plus derivative of a square by 2 is constant, derivative of sine inverse x is 1 by root under 1 minus x square times the derivative of x by a is 1 by a. Again I want to repeat is, in this part a square by 2 is constant, derivative of sine inverse x is 1 over root under 1 minus x square times, but here instead of x by a is given, so again x by a is differentiating x by a with respect to x, that's why it is 1 by a. Now moving to this step, 1 by 2 first x, and as like previous part, derivative of x a square minus x square to the power 1 by 2 with respect to a square minus x square times derivative of a square minus x square with respect to dx plus derivative of x is 1 root under a square minus x square is remaining plus a square by 2. Here 1 minus x by a whole square. By taking LCM, it will be a square minus x square under root, then it will be a square minus x square over a. So a goes up, this is a, and times 1 by a, these two a can be cancelled. Now 1 by 2x, 1 by 2 root under a square minus x square, the derivative, and minus 2x, because here is a square minus x square, so the derivative of minus x square is minus 2x plus a square minus x square under root, that is similar or same, plus a square by 2, here a square remaining term, here 2 times a square minus x square, it is as it is. Then we should take we can cancel these two, x and x, minus x is minus x square, and taking root under a square minus x square is a LCM, and first numerator is minus x square, second numerator is product of these two, that is a square minus x square, plus a square by 2 root under a square minus x square. Now minus x square is minus 2x square plus a square by 2 times root under a square minus x square plus a square by 2 times root under a square minus x square. Their common LCM is the same, minus 2x square plus a square, by adding these two, 2a square minus x 2x square by 2 times root under a square minus x square. By taking 2 common, a square minus x square by 2 times root under a square minus x square, 2 to cancel. A square minus x square can be written as root under a square minus x square times root under a square minus x square by root under a square minus x square. These two 10 we cancel, equal to root under a square minus x square. Therefore dy by dx equal root under a square minus x square is the answer for this question. Now the next question is find dy by dx if y equal to tan inverse root under 1 plus x square minus 1 by x. So to solve these questions, let's start. Y equal to 2 tan inverse root under 1 plus x square minus 1 by x. In this case, let's think in different way. Tan inverse x is 1 upon 1 plus x square. In that way also we can move, but that is little bit difficult. In previous questions also, by supposing y equal to sine x equal to sine theta, or like that way also we can solve. Let's see the different pattern in this question, dear students. So put x equal to tan theta. If we put x equal to tan theta, then why we are supposing 1 plus tan square theta is root under sec square theta, we will get sec theta. So that we can change into the next pattern. That's why we have supposed x equal to tan theta. Last year in grade 11 also we have discussed such questions, supposition method we have solved. So dx by d theta, differentiating both sides with respect to theta, d by d theta of tan theta. Tan theta is sec square theta. We know that if we suppose x equal to tan theta, then dx by d theta is sec square theta. And here y equal to 2 inverse root under 1 plus x square minus 1 by x becomes, this becomes 2 tan inverse x square is tan square theta minus 1 by x is tan theta. We substitute the value as we suppose x equal to tan theta. 2 tan inverse 1 plus tan square theta is sec square theta is root under sec square theta is sec theta minus 1 by tan theta equal to tan inverse sec theta is 1 by cos theta minus 1 by tan theta is sin theta by cos theta. To tan inverse 1 minus cos theta, 1 minus taking LCM cos theta, 1 minus cos theta, 1 minus cos theta by cos theta, and cos theta goes up times cos theta by sin theta, these two cancel. So to tan inverse 1 minus cos theta by sin theta we obtain. And to tan inverse 1 minus, here cos theta is 1 minus 2 sin square theta by 2, half angle formula we have applied, and sin theta is 2 sin theta by 2 cos theta by 2. Then 2 tan inverse 1 minus 1, this becomes plus minus, this minus makes plus, 2 sin square theta by 2, 1 cancel, 2 tan inverse 2 sin square theta by 2, 2 sin theta by 2 cos theta by 2, these two cancel, and sin square and sin theta by 2 cancel, 2 tan inverse sin theta by 2 cos theta by 2 that is 2 tan inverse tan theta by 2 sin theta by 10 theta cos theta by 2 is tan theta by 2. 2 tan inverse tan theta by 2 is tan inverse tan theta by 2 is theta by 2. 2 times theta by 2 is theta. Therefore what we obtain, y is theta we obtain. Now differentiating with respect to theta, dy by d theta equal to d by d theta equal to 1. So what we obtain, dy by d theta is 1. But our condition is to find dy by dx. So dy by dx is dy by d theta times d theta by dx. So dy by dx is 1, and we know dx by d theta equal sec square theta. So the reciprocal is d theta by dx equal 1 by sec square theta. 1 by sec square theta. Dy by dx equal to 1 by sec square theta is 1 plus tan square theta equal 1 over 1 plus tan square theta is, as we suppose x is tan theta, that's why tan square theta is x square theta. This is the final answer for this question. Now next question, our next question is, if x to the power y is e to the power x minus y. Let me read it again. X to the power y equal e to the power x minus y. Prove that dy by dx equal log x log ex to the power minus 2. We have to prove this. So here x to the power y equal e to the power x minus y. In general, if power is given, we will be taking log on both sides. Log on both sides. We will find the derivative with the help of log. So log x to the power y equal log e to the power x minus y. We find this. Power goes to multiply as a coefficient. Y times log x equal x minus y times log e. Then y log x equal x minus y log e is 1. Log, in that case log base e, that is 1. So log is log with base e we have taken, that is understood for us in this case, and log base e is 1. That's why x minus y. Now differentiating on both sides with respect to x, then we get d by dx of y times log x equal d by dx of x minus y. D by dx of y times log x equal d by dx of x minus y. Now moving to the next part. Here first notch-in derivative second, second notch-in derivative first. Product property we have to apply. Y notch-in derivative of log x plus log x notch-in's derivative of y equal derivative of x minus derivative of y. Then y as it is, log x derivative is 1 by x plus log x as it is dy by dx equal derivative of x is 1 with respect to x minus dy by dx. You can change this to shift to the right. Log x dy by dx plus dy by dx equal this one is this minus y by x. Then dy by dx is common. Here is log x plus here is 1 times dy by dx equal x minus y by x. Then dy by dx equal x minus x, x minus y by x divided by 1 over log x plus 1. Then dy by dx equal x minus y by x log x plus 1 is y log x by x log x plus 1. Denominator is same, but numerator is x minus y is y log x. X minus y is y log x, which is already given, or we find. Look at here. Look at here. X minus y is y log x. From here, from this step, we substitute x minus y equal to y log x. And again, from the same condition from here, x is what? X, you can shift to y plus y log x equal to x equal, while taking y common, 1 plus log x, so it goes to divide y is x by log x. So y is x by log x from the same relation. So in this step, dy by dx equal y is x over 1 plus log x times log x by x log x plus 1 is given here. So y value we find, the value of y is first x minus y replaced by y log x, and again the value of y is x by log x, 1 plus log x. So x cancel, dy by dx equal, this is log x plus 1 plus log x whole square. This is 1 plus log x, this is also 1 plus log x. 1 plus log x whole square equal, this is log x by 1 is what? Log base e and log x whole square. 1 we replace as we replaced previously, log e plus log ex. Now dy dx equal to log x by log a plus log b is log ab. We know that. So log base ex whole square, and the power goes to up by making negative 1. So log x log ex to the power minus 2, hence proved. We can prove this condition. Now the next part, next question, important question, interesting question is, if sine y equal to s sine x sine a plus y, prove that dy by dx equals sine square a plus y by sine a. Firstly taken the given condition, sine y is x sine a plus y, sine y is x, you can apply the formula of sine a plus b sine a cos b plus cos a sine b. Sine y equal, you can open the bracket, x sine a cos y plus x cos a sine y. Then sine y minus this term shifted to the left, x cos a sine y equal, this remains in the right, x sine a cos y. Then sine y is common, 1 minus x cos a equal x sine a cos y. Then sine y divided by this cos y, sin y by cos y equal x sin a by 1 minus x cos a. Then sin y by cos y is 10y, x sin a by 1 minus x cos a. Then 10y equal x sin a by 1 minus x cos a. Now differentiating both sides with respect to it on both sides, then we get dy dy of 10y into dy by dx. One step jumping here, dy dx of x sin a by 1 minus cos a. Then derivative of 10y with respect to y is sec square y times dy by dx equal u v form you have to apply. Second no change, derivative of first plus first no change, derivative of second by second square. Now sec square y dy by dx equal, first no change, x sin a with respect to x sin a is a constant, x is 1 sin a plus x sin a no change, 1 derivative is 0, x cos a constant, cos is 1, so it is 0 minus now second no change derivative of first minus first no change derivative of second over second square. So in left hand side sec square y dy by dx equal first no change derivative of x sin a is a constant, x is 1, so sin a minus, but x sin a here will be minus, but the derivative of 1 is constant is 0, minus x cos a is minus cos a, so this minus and this minus makes it plus x sin a cos a by second square. Similarly left as it is 1 minus x cos a into sin a, so we have to multiply this, sin a minus x sin a cos a plus x sin a cos a, these two terms can be cancelled. Now denominator as it is, there's to cancel, then sec square y dy by dx equal to upper one is sin a over 1 minus x cos a whole square Then sec square y is 1 upon cos square y times dy by dx equals sin a over x 1 minus x cos a whole square. And simply dy by dx equal cos square y, we have to multiply shift to the right, that's sin a into cos square y by 1 minus x cos a whole square. Sin a times cos square y over 1 minus x cos a, 1 minus x cos a, that we have proved or we have derived 10y is x sin a by 1 minus x cos a in the first part, right? Then 1 minus by cross multiplication 1 minus x cos a is x sin a by 10y. Then 10y is sin y by cos y goes to multiply, so x sin a dot cos y over sin y is 1 minus x cos a. So 1 minus x cos a is replaced by x sin a cos y by sin y, x sin a cos y by sin y whole square. This is from this part derived. So squaring this, sin square y goes, no, sin a, then this step sin a sin square y cos square y x square sin square a cos square y, these two terms cancelled. Then sin a and whole square is cancelled, so sin square y over this is x square times sin a. Then sin square y, what is sin square y? We know sin y equal to x sin a plus y, so sin square y is x square sin square a plus y, so x square sin square a plus y by x square sin a, x square cut sin square a plus y by sin a, hence proved. RHS equal to RHS, hence